Okay, in this tutorial we're going to have a look at some exponential graphs. Okay, so exponential functions are those in the form of y equals a to the x. Okay, so there's a few things we can work out just based off our knowledge of index laws. So given the index law a to the power 0 equals 1, all graphs in the form y equals a to the x must pass through the point 0, 1. Because when we sub 0 in, we know we're going to get the value 1, no matter what this base value is. So we know we have to go through there. Also, since a to the power of 1 equals a, then the graph will also pass to the point 1a. Because again, if we put 1 in here, we're going to get y equals a. Okay, so we're going to go through those 2 points all the time. Also, since a to the power negative x is equal to 1 on a to the power of x, negative values for x will result in very small values of y. Okay, but they must be positive. Okay, because a 1 divided by a really big number, okay, means we're going to get a really small number, but it's going to be positive. So this leads to the appearance of a horizontal asymptote at y equals 0, which you'll see in a moment. The domain for our function is all real numbers, so we can have any x or y values, okay, but our range of the function is all real positive numbers. Okay, we get really close to 0, but we don't actually reach it. So this is what our functions look like, just in general terms. Okay, so we've got the function y equals a to the x. Okay, so you can see in the red here our horizontal asymptote. General shape is approaching it but not touching it. Okay, we can see we go through this point 0, 1 and 1a there. Okay, so remember that in order to show dilation factors, we need to indicate 2 points on the graph. So I've just said that because if we haven't translated and things like that, we really need to show these 2 points. Okay, so what would happen if we had a, say, this represented y equals, 2 to the x. So we said that one was 2 to the x. That means we would look like this. Okay, so then if we were to add y equals 3 to the x, okay, then what's going to happen? It's going to come maybe a bit lower and then come up and come up faster because we've got to go through the point 1, 3 now. But it will be below it over here because 1 on 3 to the x is going to result in smaller values than 1 on 2 to the x. Okay, so we're going to drop down like that. Okay, one specific case that we need to look at in a bit of detail is graphs in the form of y equals e to the x. Now remember, e is just our natural number, so it's just a number, okay, a very specific number. So it's going to look exactly the same, it's just we're going to go through the point 1e. Okay, now we'll have a look at what happens when we start changing around our function a bit. Okay, so now what we're looking at is graphs in the form of y equals a e to the n outside of x take h plus k. Okay, so this is going to have all of our dilations and reflections and translations involved. So we'll start off by having a look at what a does. So the effect of a, so a is a dilation factor in the y direction. So that means it's going to stretch it up. Okay, so if we started something like this, okay, we're now going to be coming through and coming up higher. Okay, if a is negative, then the function will be reflected in the x-axis. Okay, so what's going to happen, okay, with this is if we're originally like this, it's now going to be reflected down like that. And that's basically because we're taking our x values, we've subbed it in, okay, to our equation, we've got e to that power of that x value, and then we've times it to get a value this is, okay, then we've times it by a negative, so overall our y value will be negative. So that's why we end up with this reflection. Okay, if we have a look at the effect of what n has on it now. So n is a dilation factor in the x direction, so it's going to stretch out this way now. Okay, so this time, what's going to happen? Okay, if n's negative, we're going to actually be reflected in the y-axis like that. Okay. Well, I forgot to mention what happens to our couple of points that we've got here. So for the effect of a, we've got the point 0, 1, that's going to become 0a. It's going to be stretched out that way. And the point 1e is going to now become 1ae. Okay, so we're going to be multiplying it by that a value. Okay, for our n value, what's going to happen is that point 0, 1 is still going to be 0, 1. It's not going to actually be impacted at all by this one, but the point 1e is going to become 1 on ne. Okay, it's being stretched out this way. Okay, if we have a look at the effect of h, okay, h is our horizontal translation, as we usually expect. So the point 0, 1 becomes h1, and 1e becomes 1 minus he. Okay, depending on which way we go. So the effect of k now, k is a nice vertical translation. Okay, so it's going to move it up and down, and our asymptote will always be the line y equals k. So if we move it down, okay, by k units, okay, this is our k value in here. And then our point just becomes adding y on, okay, to these y values here. Sorry, k onto these y values here. So we'll have a look at sketching one of these. So what we want to do is get y equals negative 2 e to the 6 minus 2x plus 1. Okay, so the first thing we need is, of course, some axes. Okay, we need to see what's going on a little bit. Now we need to do a little bit of work here, because anytime I see something like that, I get a little bit worried. Okay, because it's really easy to end up not going the right direction when we translate. So what we need to do is we need to take our coefficient of x outside a set of brackets. It's going to be negative 2x plus 3 plus 1. Okay, so if we expand that out, we get our negative 2x again, and we would get, and we'll get positive 6. Okay, if we didn't do that, okay, then this being positive, okay, we would be thinking we're going to the left. But in fact, because it's negative here, we're going to go to the right, so we would have mucked up our translation there. Okay, we can see here that our horizontal asymptote is moved up 1, so there's no reason why I can't put that in. Nothing else is going to change that. Right, so the value y equals 1. Now you can see here that we actually have a dilation in both the x and y direction. So where we'd usually be coming up like this one here is going to reflect it down, okay? But this one here is actually going to reflect it this way too, so we're actually going to be shaped this way. Okay, it's going to be that general shape. Probably shouldn't have drawn that yet though, because we have no idea what our x and y intercepts are. Okay, so to find our y-intercept, we're going to let x equal 0, so we're going to get y equals negative 2 e to the 6, okay, plus 1. Okay, so we see that's going to be a positive value. Sorry, no, it's not. It's going to be a negative value here. Okay, e to the 6 is going to be quite big, okay, and positive, but we're going to times it by negative 2, which is going to make it bigger but negative, and then plus 1 isn't going to make enough of a difference. So it's going to be negative something here, okay, and our y-intercept is, sorry, that's our y-intercept. So we're going to be quite negative down here. Our x-intercept is when y equals 0. So we've got 0 equals negative 2 e to the negative 2 x take 3 plus 1. Okay, so I'm going to take the 1 away and divide by negative 2, means I'm going to get a half e to the, half equaling e to the 2 outside of x take 3. Okay, from here we're going to use what I call the looping method and go log to the base e of a half equals 2 outside of x take 3. And now when we think of that is log to the base e of 2 to the negative 1. Okay, bring our negative down here. Equals 2 x take 3. So I divide by 2 now, and so I've got negative a half log to the base e of 2 equaling x take 3. Got negative a half log to the base e of 2 plus 3 equaling x. And it's going to be a positive value. Okay, so I'll just draw it something like this. So we know this value here is our negative a half log to the base e of 2 plus 3, and this one here, okay, is our y equals negative 2 e to the 6 plus 1. Okay. So we need to think about what's actually happened here though too. So we said about reflecting it both directions. Okay. It's also been dilated, okay, by a factor of 2 in the y direction and a factor of a half in the x direction. Okay. We've translated it 3 units to the right because it's negative, and we've also translated it 1 unit up. See though that I didn't actually keep track of those couple of points and I'd spoken about earlier, because we're always going to need to put in our x and y intercepts if we've got them. In this case we do have both of them. We've got one x and one y, which means that's all the information we needed. If however we'd stayed original like this, okay, we've only got one, okay, then I wouldn't need to put in another point. Okay, so you just need to make sure you've got 2 points, whether it's both axes or one axis and one other point. It's up to you, but you need to make sure that you're showing 2. Okay. Also, make sure that we're nice aligned and that it looks like we're approaching our asymptote nicely, but we're not going to actually touch it or cross it. Okay. Make sure we don't do anything silly like a little flick up at the end. We can get a bit carried away and sort of go whoop and flick up. Okay. Again, that's not actually showing asymptotic behaviour, so we're just got to be a little bit careful with sketching our graphs.